How systems of equations can be used to solve word problems. This video focuses on how you can solve some word problems by defining two variables and writing two equations to comprise a system of equations. I then suggest the person watching the video pause it and solve the system using either the substitution or addition method. So that method is covered in other videos. So the steps used to solve the system are not shown on this video. I do provide the values you should get for each variable after you solve it, and I write the answer to the word problem and show you how to check your answer. So the focus of this video is on how to set up a system of equations and how to check the answer. And usually you can do this when you're looking for two things. That's sort of the key that you can define two variables and set up a system. Here's another number type problem, like a puzzle. One number is 4 more than twice the second number. Their total is 25. Find the numbers. Okay, I want you to try this by defining two variables, writing two separate equations. So put it on pause, try that, and then come back. Okay. Defining the variables is always easy when you're working with two variables. If you're looking for two things, just say first number x, second number y. Okay, one number is 4 more than twice the second number. All right, let's just call the first number the one number. So the first number, x, is equals 4 more than something. Okay, that means I have to add 4 to something, right? It's 4 more than what? Twice the second number. All right, what's the second number? 2y. So twice the second number is 2y. So we have one number is 4 more than twice the second number. All right, second part. Their total is 25. Total means you add them up. X plus y equals 25. All right, so there's your system. You should be able to solve. Using substitution would be the easiest because one of the equations is already solved for x. So it would be easy to plug in that 2y plus 4 into the other equation. So put it on pause, solve it, and then we'll go ahead and check the answer. All right, are you back with me? The numbers are 18 and 17. I'm sorry, 18 and 7. All right, let's see if this checks out. All right, don't go back to your equations. That's a mistake to go back to your algebra. You need to go back to the original word problem. One number is 4 more than twice the second. Okay, obviously 18 is the bigger number. So is that 4 more than twice as big as 7? Could you do that in your head? What's twice 7? Well, it's 2 times 7. That's 14. What's 4 more than that? 18. Perfect. Yeah. 18 is 4 more than 2 times 7, right? So you can sort of convince yourself of that. And their total is 25. Is 18 plus 7 25? Yeah. Okay, great. So the numbers we're looking for are 18 and 17. Okay. Here's a new type of problem. Sarah and Keith purchased 40 stamps, a mixture of 37-cent and 23-cent stamps. Find the number of each type of stamp if they spent $14.10. All right, the important thing here is to look and see what you're looking for. It says find the number of each type of stamp if they spent $14.10. Okay, so we're looking for how many of each stamp they bought. That's how you're going to define your variables. Okay, so I'm going to write the number of 23-cent stamps. Let's call that X, and the number of 37-cent stamps, I'm going to call that Y. Now, I usually like to write the rest of the information in a chart, although you don't have to do that. So I'm going to make a little chart here. Okay, when you're working with anything like stamps or coins or some sort of mixture things where you're mixing some things together for a total cost, you could make a little chart. And in this case, what you're talking about, I put in the first column. So I'm talking about 23-cent stamps and 37-cent stamps. The unit cost refers to how much it costs for just a single stamp. Now I'm going to do everything in terms of cents so I don't have to deal with decimal points. You could always do that with money or coins. So I'm going to say one 23-cent stamp costs 23 cents. And a 37-cent stamp costs 37-cent stamps. Okay, now I want to know how many of each stamp I'm going to buy. Well, you wrote that right up here. X was the number of 23-cent stamps. So X is the number of 23-cent stamps I'm going to buy, and Y is the number of 37-cent stamps I'm going to buy. The total cost, if you buy X 23-cent stamps, each one costs 23 cents, so that's 23X for the total cost. So notice I'm doing the unit cost times the number of stamps is going to equal the total cost of the 23-cent stamps. So that's the total cost of all the 23-cent stamps that I buy in cents, and the cost of the 37-cent stamps is 37Y. Now let's look back at the original problem. It says they purchased 40 stamps. Okay, that's talking about how many stamps they purchased. And this column, the number, tells you how many stamps they purchased, right? They purchased X of the 23-cent stamps, Y of the 37 stamps. So they purchased 40 stamps. Does that make sense? What was the total cost of all these stamps? $14.10. Remember, I'm doing everything in cents, so I'm going to put 1,410. These columns really add up to your equations. So I have two equations right here. X plus Y is 40 will give me one equation, and 23X plus 37Y is 1410 will give me my other equation. So these are going to be your two equations. That's your system, in other words. And now, that's the hard part, right? Getting the equation. The easy part is solving it. You could use a calculator, although you shouldn't have to use one, but you can use one to solve this system of equations. So I want you to solve this using the addition or the substitution method. Put it on pause and then come back. Okay, if you solve this, you should have gotten that, let's see, you should have gotten that X equals 5, and you should have got Y is 35. But the problem, there was no X and Y originally. Remember? You have to know what X and Y stand for. X is the number of 23-cent stamps. So I've got number of 23-cent stamps. There's 5 of them, right? And the number of 37-cent stamps looks like there's 35, if this is correct, and which we'll definitely make sure by checking. All right, so let's check. Okay, so I have to kind of look back at the original problem here. It says we've got 40 stamps. All right, first of all, well, does 5 and 35 add up to 40? Yeah. Okay, that was the easy part. Sure. Did add up to 40. Okay, also, it says that, you know, the total cost of this number of stamps is $14.10. So let's see the cost. All right, so for the 23-cent stamps, look at here. I've got 5 23-cent stamps. So that's going to be 5 times 23. So you could use your calculator. Let's say, I think that's 115. But I'm going to use 5 times 23 cents. Okay, that's really $1.15 if we're talking money. And then I've got 35 of the 37-cent stamps. You can multiply that out the long way or use a calculator. That's $12.95. And we add that up, and yeah, it does come out to $14.10. So that was the correct answer. They purchased 5 23-cent stamps and 35 37-cent stamps. So again, we're focusing on defining the variables, writing two equations. Some people don't need this chart. You could simply go right to the equation. That's fine if that makes sense to you. Sometimes it just helps to organize your information.